Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. Now, in today's video, we're going to be looking at multiple choice questions under reaction rate or rate of reaction. Okay, yes. Sorry. Now, the first question says to us, let me change my highlighter. A reaction is mostly likely to occur when the reaction particles collide with proper orientation and, let me zoom that, and what? Remember for particles to collide effectively, we need what? We need what? Correct orientation. Let me rewrite that. I'm saying we need correct orientation, and enough or sufficient kinetic energy. Kinetic energy. So now, here, even though the wording is not necessarily good, so we need a proper orientation and a proper what? And proper energy. So instead of proper energy, you need what? You can say sufficient or enough. What energy? What type of energy? Kinetic. To be more specific. Okay, yes. The second question says, catalyst can increase the rate of reaction by providing a what? Remember, by providing an alternate path, okay? Alternate pathway with lower activation energy. Remember, what is a catalyst? A catalyst is a substance that increases the reaction rate, okay, by lowering the activation energy, okay? So now let's look at our answers. Options: an alternate path, okay, yes, with higher kinetic activation energy. No, remember, it lowers the activation energy. So this is incorrect, making it A. Wrong. The same, not the same pathway. So since it's wrong, it is wrong. The alternate reaction pathway, okay, with lower activation energy. Very, very true in this case. So now that makes C the answer that you might think it is correct. Here, the same pathway, no. Remember, it is not the same pathway, but rather the what? An alternate path, okay, pathway. So this one will not be correct. So the most correct answer in this case, it is number C. Minimize that. Okay, they say the mass of a catalyst was determined at time interval. Which one of the following graphs best describe the mass of a catalyst? Remember, a catalyst, okay, it does not undergo any permanent change. What do I mean? Remember, the definition says it is a substance that increases the rate of reaction by lowering the activation energy without undergoing any permanent change. So it means I do not expect any change on the what? On the mass of the catalyst. So this makes B the most correct answer. Okay, yes. I don't need to explain these graphs, no. What I need, it is the definitions. It does not undergo any permanent change. Here we have Maxwell distribution curve for a reaction mixture is shown below, okay? So now let's see. They say the temperature of the reaction mixture is now decreased, okay? Which one of the following graphs, okay? Remember, when the temperature is decreased, let's say here we have EA, okay? Remember, what will happen? The number of particles will decrease by how? Remember, if the temperature is decreased, it will become narrower and something like that. Let me retry that. Maybe something like that. Why? Because I said, remember on the video where I explained this topic, I said now when the temperature is decreased, it becomes narrower and then like that, okay? And it has the highest peak and it becomes narrower, okay? But I said if temperature is increased, remember if temperature is increased, it was gonna be broader and like that, okay? Can you see the peak is lower and it is broader, meaning it is wider. But in this case, we are talking about the degrees. So which graph is that? This one, it is a concentration. Hence, it is wrong. Remember the concentration, if it is increased like that, if it is decreased, it's going to be like that. So this is concentration. This one, it is yes. Yes, it is the correct answer. Why? Because now, can you see the dotted lines? A new distribution curve, it is this one. So the dotted lines, if I do, can you see? It is now narrower and has the highest peak, okay? Then here, this one is a higher temperature. Higher temperature. This one we don't know it. Does not exist. Okay. Remember, if it has to lower the peak, if the peak is lowered, it should be broader. This does not exist on the Maxwell distribution curve. Okay. So the most correct answer is A in that particular case, the off. Then they say to us, consider the synthesis reaction of ammonia NH3. Okay, so remember the synthesis you are forming. Okay, so now the rate of N2 consumed during the reaction is X mole per decimeter cubed. So the rate of N2, it is X mole per decimeter cubed per second. Okay, so this is the rate at which this is consumed. Okay, so which one of the following is the rate of ammonia produced in mole with respect to N2? So just say N2 and say ammonia. The ratio, it is 1 is to 2. Then the rate of N2, it is X. Then what is the rate of this one? Let's just say the rate. We are looking for the rate of NH3. Okay, so you're gonna say rate multiplied by 1 is gonna be rate is equal to 2x. So the correct answer, it is what? 2x the off. So the most correct answer, it is that one. Another thing, even if you did not need to come here, you'd say, okay, if I have 1 mole of N2, I have double of that. So similarly, if the reaction rate is say a 1 here, so it means on NH3 is going to be double of that. Okay, but it's good that I also proved using calculations. Then we have a question that says, while a chemical reaction takes place, the rate of reaction does what? Remember, while a chemical reaction occurs, the rate of reaction will decrease. Why? Because reactants are used. Or we'll say reactants decrease. So let's see which one of the following is the correct answer. Remain constant, no. Decrease, yes, because concentration of the products decrease, no. Not the of the product. This one is correct, but this one is not correct. Not of the product. Okay, it increases, no, it does not increase, it's wrong. It decreases, yes. Why? Because the concentration of the reactants decrease, yes. So the most correct answer, it is D4 for 2 marks. Okay, when zinc 2 carbonate, okay, so zinc 2 carbonate, okay, because carbonate has 2 minus like that. I think it's going to be ZN2 like that, or however. Okay. React with excess hydrochloric acid, carbon dioxide is produced. Okay. The graph below were obtained under 2 different reaction conditions. Okay. The change in graph from S to R, okay, could be brought by, okay, check, from S to R, okay, what could happen? This is the first one, this is the second one. So can you see here, the rate is equal, the rate is the same, okay? The rate is the same, but now it produces now what? It produces more, okay? If it produces more, this cannot be temperature. cannot be temperature because temperature only increases the reaction rate. Temperature increases the reaction rate but produces the same amount, okay? This cannot be a catalyst. This cannot be catalyst. Remember, we have temperature, catalyst, concentration, as well as mass, okay? This can be mass, okay? Mass, okay, this can be mass, but this cannot be concentration. Why? Because if it was concentration of excess hydrochloric acid, already it is in excess, okay? So it will just increase the reaction rate. But remember, since it is just concentration is gonna increase the reaction rate, but it will produce the same. The only time you produce more, it is when you add a mass, if your mass is increased, okay? So the correct one that we are looking for, it is an increase in mass. If you increase mass, I think this graph is drawn badly also. If you increase mass, you will increase the reaction rate, you will also increase the product that you are forming, okay? So the graph, it is drawn badly. I excuse the examiner there. Okay, so now let's see, decrease the concentration. You cannot decrease the concentration. Increase the mass, indeed. You need to increase the mass, okay? Decrease the particle size. If you decrease the particle size, no. Adding a catalyst, when you add a catalyst, it will just increase the reaction rate, but can you see the amount of volume produced there will be the same, okay? So adding a catalyst is not correct, but increasing the mass of zinc carbonate will now lead to more. Remember, if we have more zinc, okay, if we have more zinc thereof, which is in a form of mass, if we have more mass of zinc, okay, we will produce more carbon dioxide, okay? So hence we need more mass here so that we increase that one, okay, cool. 1.5 say, there's another multiple choice question. Which one of the following changes will take place if the temperature of a reaction mixture is increased? Now, if the temperature is increased, the first thing that I know, it is the rate will increase, the reaction rate will increase, okay? There will be more effective collisions. Actually, let me do this. Average kinetic energy will increase. Therefore, EK will be greater or equal to EA. Okay, more particles will have a kinetic energy that is greater or equal to EA. Therefore, more effective collisions. Collisions per unit time. Therefore, the reaction rate will increase. Let's look at those options. The rate of direction will increase, very correct. The frequency of collisions increases. The frequency of collisions increases, okay? Remember, frequency, it is 1 divided by t. So it already has per unit time. So hence now we are going to say this is also correct. Instead of saying more effective collisions per unit time, you can say more frequency, the frequency of collision will increase, okay? So if this will increase, it is per unit time, okay? The average kinetic energy of particles remains constant. You are lying. Okay, the average kinetic energy of particles will increase, okay? Because now, remember, I did an example of boiling water. If boiling water, this is cold water. If I increase my temperature there, the boiling water will do what? Will do blah, 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 will do bubbles, will start to move faster. So hence we are seeing the average kinetic energy of particles will not remain constant, will rather increase. So the most correct answer is 1 and 2 only. Okay, which is option A in this particular method thereof. Then now we are told that the curve X and Y show the volume time, okay, the volume time relationship for the following reaction: zinc H2SO4, then it forms zinc like that in blood. Then now curve X and Y are produced under the same conditions. However, the same conditions, right? However, curve Y is produced by adding an aqueous solution of copper sulfate, okay, to the reaction mixture. Now, what will copper sulfate do? Copper sulfate, it is something like copper sulfate. So now we'll have, see, like this. This one will act as a catalyst, okay? Will act as a catalyst. Copper ions act as a catalyst on a reaction, and it will be true because now why? Remember, a catalyst increases the reaction rate from X, will increase the reaction rate, but will produce the same amount of a thingy of volume. Okay. Now, which one of the following correctly explains why curve Y is different from curve X? Copper ions acted as a catalyst. This one, let's put a question mark on it. Okay. The concentration of sulfate ions increased. No, we do not care about sulfate ions, whether they increased or not. Okay. This is not an ion effect reaction. If it was an ion effect reaction, like maybe something like H2SO4 2 minus, the reaction that has charges here, it is what we call the ion effect. If that was the case, therefore we will have said, okay, the copper concentration of sulfate ions increases, but no, this is just a normal reaction, okay? Therefore, zinc displaces the copper from the copper sulfate. No. How? The statement means now zinc was displaced. The zinc displaces the copper from the copper sulfate. No, I can't even understand that statement, but it is incorrect. The change in the concentration of sulfuric acid decreased per unit time. No. Remember, I don't care about the sulfuric acid, concentration of sulfuric acid. If it decreased, the reaction rate should have decreased like that. Maybe something like this, but end up forming the same. Okay. But now that's not the case. So the most correct answer in this case, it is A. Copper ions acted as a catalyst. So then let's look at our last question. Our last question thereof, we have now two different types or two different samples of impure, okay, calcium carbonate of equal masses react with 0.1 mole of H2SO4, okay? Assume that the impurities do not react. So we know if the impurities do not react, only the pure react, okay? The graph below shows the volume of carbon dioxide produced for each reaction. When compared to reaction 2, okay? When compared to reaction 2, which one of the following statements best explained the curve obtained for reaction 1? Can you see now, for reaction 1, it produced that, okay? But for reaction 2, the rate was higher, it produced also the rate was higher, it also produced more carbon dioxide. And remember, both of them are impure, okay? But we were told that only the pure reacted. So it means now this one had more purity, more pure mass. Okay, let me say reaction 2 had reaction 2 had more pure mass than reaction 1. Why am I saying that? Because if reaction 2 has more pure mass, I'm talking about pure mass. I know this is impurities, but remember they said assume that impurities do not react. So it means now reaction 2 had more pure mass than reaction 1, or you can say reaction 1 had more impurities than reaction 2. So if these two cases are true, then hence now reaction 2 produces more. So let's say in reaction 1 and reaction 2, remember they said the impure are equal. Okay? The impure, let's say the impure is 10 grams. Similar here, the impure it is 10 grams. But now what about the pure? What if the pure here was 6 grams and the pure here was just 4 grams? Can you see now the mass here of the pure which reacted is greater than Sorry. For reaction 1 was low. Okay, for reaction 1, the purities, let's say maybe were 4 grams, this were 6 grams. Can you see now, if this one mass is low, it means now the rate will be lower compared to this one. Similarly, this one will produce more carbon dioxide, produced. So now let's see the statement that we're given. The temperature is high. We don't care about the temperature. Okay, if the temperature was higher, okay, it would have been higher, but now producing the same amount. Okay, the only one that can produce a higher amount, it is when the mass is involved. Okay, the surface area is greater. If the surface area is greater, it will have increased the reaction rate, but since, well, it is the same amount of surface mass is gonna produce that, the same amount of carbon dioxide. The amount of impurities in reaction 2, okay, the amount of impurities is greater in reaction 2. No, the impurities in reaction 2 are low because there is more pure. So now remember I said reaction 1 had more impurities than reaction 2. So this one is also wrong. The amount of impurities is greater in reaction 1. This is the most correct answer thereof. Remember I did explain that reaction 1 had more impurities than reaction 2 though. So that makes D the most correct answer. So yes, that's all from our multiple choice questions thereof that I had. Okay, so yes, thank you very much for joining me here thereof. Let me do that. Let me quickly do that. Okay, yes, thank you for joining me in this video. I hope now you understood the multiple choice questions that we went through. Okay, they are just giving us an overview of what this topic is about. Okay, so yes, thank you very much. I hope you enjoyed the video, and if you did, please join me again on the series of videos that I'm gonna be recording. Thank you very much.